out a link when I'll send out a link when I have this generated. All right. So in general, functions model a relationship between two interrelated quantities. So typically you'll hear the language of input and output. I'm sorry, am I still sharing?
No.
Okay. That's a problem. So again, functions model the relationship between two interrelated quantities. You've probably heard the language of inputs and outputs before. So in this case, our independent variable would be the output variable. So whatever 3 represents, I want that function to tell me, all right, when you have 3 of this quantity, it results in f of 3 of some other quantity. So the context will dictate what the quantities are and how they're related. So having said that, let's look at a context here. So this first example, let's say the number of calories that you burn is a function of the number of minutes that you exercise. So we'll call that function f. So we have our function f. I have told you what the independent variable represents, and I have told you what the dependent variable represents. So I'm going to give you all a couple minutes here. So I have f of 95, f of c equals 140, and f of z minus f of 40. So I'll give you a couple minutes here, and when I come back, I'm going to get some volunteers to tell me what each of those 3 pieces of function notation means. Right, I'll see you in a couple of minutes. So I have a question from Edward asking if we need to write these down. Not necessarily, just be ready to answer me if I volunteer you to answer.
I'll volunteer.
Okay, who was that?
Mark.
Okay, Mark, I'll call on you in just a bit. I'm going to give you all a few more seconds. Thank you, though. All right, let's go ahead and start. So, Mark, go ahead and take the first one. What does f of 95 mean to you?
F of 95 means the number of calories that you burn in 95 minutes of exercise.
Okay. So, number of calories you burned in 95 minutes of exercise. How do we feel about that? Anybody have something a little different, maybe?
I mean, you could say like the first 95 minutes, because it's like if C means minutes since starting the workout.
Mm-hmm. Okay, so yeah, it could be the first 95 minutes, but really, when you're interpreting, I mean, there's an infinite number of ways you can describe what's going on here. But I like what Mark said: the number of calories you burn when exercising for 95 minutes. I think mine and his are not quite exact, but they do have the same meaning. All right, somebody else. What is f of c equals 140? What does that represent?
I can take this one.
Okay, Ramon, go ahead.
So I think what this one means is that after C amount of minutes, you'll have burned 140 calories.
After C amount of minutes, you will have burned 140 calories. How do we feel about that? Okay. I think that sounds pretty good. You exercise for C minutes and burned 140 calories. And finally, F of Z minus F of 40.
That could be the difference in calories burned between 40 minutes working out and Z minutes of working out.
Okay, so the difference in the calories burned between 40 minutes of working out and Z minutes of working out. Anybody have anything a little
Would it be
different?
reasonable to call that could we call that the net calories burned between 40 minutes and Z?
Okay, so we're using the language of net calories burned. And that's definitely another way to state that. I don't think I use that language, but like I said, there's many ways you can say this. The change in calories burned from 40 minutes of exercise to Z minutes of exercise. So I believe John used the word, the difference in calories burned. So many different ways to say these ideas, but yeah, difference, change, a net result. Now, all these things kind of hit back at the same idea. Any questions here before I move on to the next one? All right. All right, so now I'm giving you a different context here. So I want T to be the time in seconds since a race car began moving after a pit stop. And I want capital D to be the distance in feet traveled by the car since it first started moving. Which of the above quantities is independent and which one is dependent?
Okay, so the independent variable is time and the dependent variable is distance.
Okay, so Mark says independent variable time and dependent variable is distance.
Yep, I agree with that.
We agree? Okay. And the chat says a couple of agreements there as well. Right. And so, yeah, I mean, for me, I think it's easier to think about which one is the dependent variable. So if you have two variables, which one is governed by the other? And in this case, distance is governed by how long you've been driving, for how much time you've been driving. So time should pretty clearly be the independent variable. And as Ben has stated, time is usually the independent variable. It won't always be. But in this context, I think it's safe to say independent variable is time and the dependent variable is D, distance. So now we're going to go the opposite direction. So T is the independent variable, D is the dependent variable, and the function that unites them, let's call it W. So now I want to use function notation. Now I'm going to give you the English, you give me the function notation. So for A, B, C, and D there, take another couple of minutes and give me translate those English phrases for me into function notation, and I'll be back around 12:25. Or I guess, what do we think, was 2 minutes about the right amount of time for the last one, or do you need a little more?
I thought 2 minutes was good.
Okay, we'll stick with that then. And please don't be afraid to tell me if you need more. We're in no real hurry. All right, I have 1225. So who wants to give me something for part A here?
I
Is-
will.
Oh.
Sorry.
Sorry, Mark, I'm gonna go ahead and let somebody else have a chance. Who else chimed in?
I did.
Okay, go ahead.
Is it W of 9 is equal to D?
Okay, is it Angel? Pronounced Angel?
Yes.
Okay. Angel says W of 9 is equal to D. Anybody want to add to that, amend it, something else? The chat says Alistair agrees.
Do we need the equals? Do we need the equals to D, or would it just be W of 9?
I just have W of 9. So yeah, you're Angel, you're exactly right. If I did want if I was looking for the value of the independent variable, I would get it by, taking the value of 9 and using that as an input to a function that we're calling W. But yeah, the function notation W of 9 will give that D value that you're looking for. All right, how about part B? All right, I have a couple in the chat that I want to talk about. So the first two answers I got in the chat, one from Alistair and one from Min2. By the way, if I am pronouncing anybody's name incorrectly, please tell me. I feel like students have the feel like they have to just go with what their teacher calls them. That is not the case. If I'm mispronouncing your name, I definitely want to know about it. So Alistair says W of 5 minus W of 2. But Min2 says W of 5 minus 2. So obviously different. I want to talk about the kind of what they say there. Do we agree with W of 5 minus W of 2?
Wouldn't that just give
I do.
the I feel like, because I mean it depends completely on the function. It could be the same, but I feel like that would give you just the value of W of 3, which could be a completely different number.
Yeah. And Ramon, you're exactly right.
Yeah.
So when you have 5 minus 2 in the parentheses like that, then order of operations dictates that your input to that function is going to be 3 seconds. So we definitely want to evaluate the function at 2 seconds, evaluate the function at 5 seconds, and find that difference. So because of that, I think W of 5 minus W of 2 is the right way to go. All right, how about the car's change in distance in its third 4-second interval? All right, Dong says W of 12 minus W of 8. Ben agrees with him. So does Kevin. All right, so W of 12 minus W of 8. Let's see. W of 12 minus W of 8. Very good. All right, and then finally, the change in distance over any 7-second time interval beginning at some time of X seconds. Our chats are pouring in. All right, so I have some different ones here that I want to talk about. So I have W of 7 minus W of X. W of X minus W of X minus 7. I have W of X plus 7 minus W of X. Does that account for all the different ones I have? I think that accounts for all of them I have. So let's do it. Let's do this. Here's what I have. I have W of X plus 7 minus W of X. So obviously we have a lot of similar things, and I want to talk about what makes them different. So let's start with this. The first one I saw is W of 7 minus W of X. What would that represent? W of 7 minus W of X.
That would represent the difference in the distance between 7 and X.
So let me figure out if I can, oh, I can type it. Yeah. So if we have W of 7 minus W of X, yeah, I'm taking a difference of, you know, I don't necessarily have a 7-second interval there. I just have two time values, 7 seconds and X seconds. I have no idea how far apart they are. Another one I saw, I think, was this. This one is close, but it's not quite what I was asking for. What would this here in the blue, what is that going to give me?
It's similar in the sense that it is a 7-second time interval, but I think this one's beginning at X minus 7 instead of beginning at X. Like
Right, that's
the
exactly
question
right.
asked.
So I am getting a change in distance over a 7-second span, but I would argue that this is the interval that ends at time equals X, and not the one that begins at time equals X. So that's a tricky one, and the only reason I'm highlighting some of these other answers that I totally expected to see, by the way, is just to show you kind of, you know, they're very similar both in meaning and in syntax, but we want to be very, very careful. You know, I keep going back to the example of finding the volume of a solid using integration. It's going to be pretty common for a lot of you all to, you know, you might use 4 different functions to actually get that result. And it really is important to make sure that all those functions are, they say exactly what you think they do. All right, let's go ahead and move on. Let me clear my annotations. All right, same context. W is the same function we just had before. But now I'm giving you the function notation, and I want you to give me the English. So I got 1232. I'll come back to y'all at 1234. All right, let's get started. The first one, 2W of A. What does that mean? All right,
It
D
means
says,
the
go ahead, Mark.
distance of the car in 8 seconds multiplied by 2.
I also have in the chat from D, the first one is twice the distance traveled after A minutes. Aniket says the two times the distance since A seconds. Right. I do believe time is was in seconds, right? So just kind of a caveat there to when you're defining variables, make sure you know in what units they're expressed in. I believe this was seconds. Yeah, it was. So twice
Do
the
we get
distance.
units for distance?
I believe so. I can go back. Oh, that's bad. Let's call it feet. Thank you for that. Yeah, it's definitely a miss on my part. So twice the distance traveled by the car after 8 seconds. All right. Next one, W of C minus W of 8.
I said the change in the distance in feet from a starting time of 8 seconds to C seconds.
Okay. Dong says the change in distance from 8 seconds to C seconds. Edward says the distance difference as C seconds and 8 seconds. So yeah, the distance traveled between T equals 8 and T equals C seconds. Yeah, the difference in, the change in, a lot of these things represent the same idea. Right, next, W of 7.5 minus W of, no, sorry, minus 9.
That would be the distance at 7.5 seconds minus 9 feet.
Okay. So Caitlin says the distance at 7.5 seconds minus 9. 9 feet short of the distance traveled in 7.5 seconds, 9 feet less. So yeah, sounds like nobody fell into my trap of trying to take a difference between times here. It's the difference between, so there's a distance that the car travels in 7.5 seconds. I want 9 feet less than that. So 9 feet less than the distance traveled after 7.5 seconds. And finally, W of 3 plus H minus W of 3. Ben says the distance between 3 seconds and 3 feet after H seconds. Ben says wrong unit. Which one, Ben? Distance traveled over an interval of H seconds. Distance between 3 seconds after H seconds and the distance traveled in 3 seconds. That's good. Dong says the change in distance from T equals 3 to T equals 3 plus H. A lot of these look really good. One thing I will highlight is it's not quite enough to tell me how long the interval is. I need to know when the interval, I need to know how to locate that interval. Yes, the interval is H seconds long, but is it the first H seconds, the last H, somewhere in between? So kind of a rule of thumb, you can't tell me too much information, provided that it's all correct. So yeah, it's an interval of H seconds beginning at T equals 3 seconds. So the distance traveled in the H seconds after T equals 3 seconds. Any questions on any of these so far? All right, I believe these are my last two. I'll give you another minute or two on those, and I'll come back to you. All right, for this top one, I'm going to tell you right now, the top one is dealing with an interval. So answer me these two questions. When does the interval begin? And how long is the interval? I have an interval of 10 seconds beginning at t, interval of 10 seconds beginning at t seconds. Anyone have any disagreements with that? Doesn't seem that way. Yeah, that's absolutely right. So I have an interval starting, or interval. I keep saying interval. The distance traveled in the 10-second interval following starting. Starting at t seconds. Right, there's another edit that has to happen. So distance traveled in the 10-second interval starting at t seconds. And then this last one, w of x plus 0.5 minus w of x, all divided by 0.5. So I have the average rate of change of function w over a half a second interval beginning at time equals x. Ben says the average distance in the half second after x. Michael says half the distance traveled. So I want to go back to, I think it was Jillian Garner. Jillian, why did you say it was an average rate of change? What clued you into that?
So the top half of the ratio, or I don't know, the top half was distance and the bottom half was time. And so it was measuring the difference in time. No, it was measuring the difference in distance over the difference in time.
Okay.
So,
That's good. And one thing I want to highlight, just to make it a little more clear, make it a little more specific. In the numerator, how long is that interval indicated in the numerator? How many seconds?
Half a second?
Half a second. So if I want the distance traveled in a half a second divided by half a second, I'm going to get an average rate of change, an average speed. So average speed of the car for the half a second following x seconds, whatever x seconds is. Any questions for anything we've talked about so far? All right. So I thought that GC assignment was due tomorrow, but if he hasn't given a due date for it yet, that may not be the case. So here's what I would like to do right now. I have 12:43. I'm going to go to Canvas right now and open up that quiz so y'all can take it. And I will stay in the room for a little while, just in case you have any question about what's going on in class so far, anything we did in recitation, or if you want to talk about GC, I'll hang out in the room. Otherwise, I'm going to head to Canvas right now and publish the first quiz.
Is the GC assignment you're talking about the homework GC intro?
Yes, that's the one. So
Okay.
even though I don't see a due date for it, I'm hoping that hopefully you've taken a look at it. If not, I would definitely try to take at least start it today, because I have a feeling the due date is going to be sometime this week. All right. The quiz
Cool,
should be
thank you.
published. It has a passcode, which I am putting in the chat right now. If anybody has a problem getting in, please let me know. But you should have 15 minutes to get that done, starting whenever you open it.
Where did you post the quiz?
If you go to home, sorry, not home, go to assignments. You will see one of these headings is called recitation quizzes, which right now should have one thing in it. It's called R01 function notation.
Oh, okay, I see it. Thank you.
Passcode isn't working. It says it's not working.
This is not open?
Like the passcode is not working.
It worked for me. It's an uppercase S.
Yeah, it should be, yeah, capital
Oh,
S-U-N-S.
uppercase. Okay, I'll
Yeah.
try uppercase.
Okay, yeah.
I got it.